our respected principal, Dibakar Dev, for his constant encouragement and support. My sincere also goes to our HOD, Dr. Pulak Sen, for initiating and guiding the organizing of this program, and also our IIC convener, Dr. Siddhartha Shankar Dev, for extending continuous support IIC of the Techno College of Engineering Agartala. I also thanks all the faculty members of Mechanical Engineering Department of their cooperation and coordination in successful arranging today's event. Now, without further delay, I kindly invite Dr. Shishendu Das, Associate Professor of Mechanical Engineering, to deliver the.
Good evening, everybody. On behalf of Techno College of Engineering, Agartala, I extend my warm and heartfelt welcome to all the participant faculty members, students, and the distinguished guests who have joined with us in this particular session of Industry and Academia, which is organized by the Department of Mechanical Engineering in collaboration with the Institute Innovation Council of our institute. So this particular session is very much essential and important because here we will discuss about two vital pillars of the progress. These are the industry and the academia, because nowadays the technology is growing very fast, but the syllabus which are followed in the academics, the upgradation of the syllabus is not in the same respect of the change of this modern technology. So obviously, as a faculty of this particular domain, we always feel this there is some gap, and we need to bridge this particular gap. So we are deeply honored to have with us our esteemed guest and speaker, Dr. Atosh Kumar Sinha, material science engineer and R&D expert from the Offshore and Marine Engineering Private Limited, Ahmedabad, Gujarat. Sir, your vast experience in the field of material science, your research and your industrial experience will obviously enrich this particular session, and we are thankful that you have taken time from your busy schedule to share one evening and your expertise with our student and with our faculty members. My greetings to all the faculty members of the Department of Mechanical Engineering and our Institute Innovation Council for organizing this type of valuable session for all of us. And once again, I welcome all the participants, including the faculty members, student, and the industry expert in this particular session. Let us make this session a session of learning and interaction. Thank you all.
Thank you, sir, for your nice and thoughtful welcome address. Now, at this moment, I would like to turn our attention of the most important part of today's program, the introduction of our esteemed guest speaker, Dr. Atosh Kumar Sinha, who has completed his PhD in Electrical Material Engineering from NIT Durgapur. PhD research work was focused on the correlation of process parameter, structure, and property of wire arc additive manufacturing of aerospace grade aluminum alloy. His expertise in the field of additive manufacturing, welding, corrosion, and finite element analysis. He is currently working as materials engineer in the Department of Research and Development at IRM Offshore and Marine Engineering Private Limited, Ahmedabad. Now, we kindly request you to please proceed and share your professional thoughts with us.
And good evening, everyone. Am I audible?
Yeah, audible.
Good evening, everyone. First of all, thank you, Dr. Rahul, for your kind welcome and wonderful introduction. So, without Dr. Rahul,
Yeah, yes, sir.
can you wait for a moment?
Yeah, yeah, sure. You take your time. We are here.
I hope my screen is visible.
Yeah, it is visible.
So, without doing any delay, let us start the So, as described by Dr. Rahul, I am done PhD from Metallurgical and Materials Engineering in NIT Durgapur and working as a materials engineer in the Department of Research and Development at IRM. So, the today's topic is the recent trend in advanced manufacturing technology. And the aim of the program is to motivate the future generation to explore the advanced manufacturing technologies to join the industries. This slide shows the outline of the presentation. First, I will describe about the company where I am working right now. Then I will proceed with industrial revolution, the manufacturing technologies and advanced manufacturing technologies which has developed till now, and India's net zero goal. So this site presents about the company. It has been established in 1964, and it is one of the largest manufacturing company which fabricates works on rubber engineering and heavy metallic products for marine and offshore components. We have testing and R&D lab in our in-house factory, and IRM Offshore and Marine Engineers has collaboration over 90 countries throughout the world. And we have expertise team of 15 years plus average experience, and the average age of the employees below 40. This slide shows the industrial revolution. So right now we are in industry revolution 5.0. The first industrial revolution has started in 1780, which is known as Industry 1.0. During this time, I'm only the steams in textile and iron making manufacturing has been established at that time. And the period of the from for the industry revolution 1.0 to 2.0 is almost taken 120 years. In 1900, the mass production and assembly line with electricity has been introduced. Now you see the time gap between the industrial revolution, the way as we progress from industry 1.0 to 2.0, has taken 120 years, and whereas in industry 4.0 to industry 5.0 only has taken 20 years. The concept of industry 4.0 was removing the human and doing everything by automation, AI, and machine learning methods. In Industry 5.0, they revised the concept and they have integrated the human as well as automation and steps. Now, what is manufacturing? Yeah, I hope it is known. It is everyone known to that. That manufacturing is a process which converts the raw material to the finished product. But manufacturing is an important part of any country because it directly strengthens the economy. enables the innovation and our everyday life. There are several types of manufacturing industries in this world. So those some as aerospace, marine, healthcare, batteries, automotive, metal fabrication, and so on. The lower part of the of this slide shows the how um, work takes place in a manufacturing industry. First, we collect the raw material according to the need of the industry. Then we plan the production and done the designing of the fabricated components. Then we go for manufacturing different type of manufacturing operations. After doing fabricating the components, we do quality control for testing the components or finished good, and then if any rework occurs, then we go for post processing to finish the product, and then we deliver the product to the clients or the humans. So the manufacturing is basically classified in two types, that is traditional and advanced. And traditional manufacturing is two types, that is formative and subtractive. Advanced manufacturing has several types which I will show later of this presentation. So now we understand what is formative and subtractive manufacturing. Formative manufacturing is such type of manufacturing method which involves the shaping of raw material into final product by applying mechanical force or with or without adding any material. The formative manufacturing is built on the focused on mass production, and it is ideal when the fabricated components are identical with each other. The some common formative manufacturing methods are for forging, rolling, extrusion, sheet metal forming. Whereas in subtractive manufacturing, the object is created by removing the excess material from a solid block. The common subtractive manufacturing methods are turning, milling, drilling, grinding, boring, and so on. The main disadvantage of those manufacturing methods are those are very time taken process, and the wastage which develops from those manufacturing methods are too large. So to increase the production rate and reduce the wastage, um, advanced manufacturing technologies is introduced, which is combination of additive manufacturing, hybrid manufacturing, advanced robotics and automations, digital twins, process monitoring, and advanced sensors, artificial intelligence, and machine learning in manufacturing and advanced material. Here there is a PPT, there is a video of advanced manufacturing technologies. Please show that this is a automotive manufacturing industry. Okay, please see this video for some time. Here you can see that the robots are handling everything to manufacture a car, and all the operations is doing by automation process. So I hope this is till now this is fine. Let's move for the further slides. So the first step of the advanced manufacturing technology is additive manufacturing. This additive manufacturing is a process where a component is fabricated by layer deposition by fusing or solidifying the layers. In additive manufacturing process, a component is fabricated from scratch to final product in a single go. The left side of the of the slide shows the how additive manufacturing takes place. First, we do the design in a CAD model. Then we transfer that CAD model in stereolithography files, and after that we slice into thin layers, and then we after the slicing we incorporate those design in the 3D printing machine, and the machine the fabricate the component in layer by layer manner. After fabrication, different type of testing is conducted, such as non-destructive, destructive, as well microstructures. The right side of the slide shows some components which has been fabricated by additive manufacturing technology till now. There are many more components which has been fabricated. These are some examples. Now, how additive manufacturing takes place is that you can understand more beautifully by these videos. So please see. This one is done by this video is about laser heat source with powder as a raw material. Here you can see the components is fabricating by melting the powder particles, and it is depositing in layer by layer and fabricating the final component in a single go. The table which is rotating, that is called as turntable or positioner. So, so the beauty of the additive manufacturing is the deposition rate of the process is very high. It is almost if we use arc as a heat source, welding arc as a heat source, it goes up to 8 to 10 kg per hour. And if the heat source is laser, then it is 3 to 4 kg per hour. Now let us focus on hybrid manufacturing. Hybrid manufacturing is the combination of additive manufacturing and subtractive manufacturing. And in this manufacturing method, if suppose some post processing is required, it can done in a single way. There is an interesting video of that hybrid manufacturing. Now you can enjoy this video by that time. You have seen that cutting operation takes place first, which is already building. Now the component is building by additive manufacturing process, and then again machining will be done. This slide shows the core of the modern manufacturing flexibility robotics and automation, with techniques like welding, painting, material handling, and machining. The next one is collaborative automated guided vehicles. The automated guided vehicles are such type of robotic where the path of the industry is already fitted on that one and as for materials to another place. Now let us focus on digital twin. Digital twin is a virtual mode of the real product machines or systems which behaves like a real product because it receives the live data from the sensors. From the sensors and the IoT device, it updates the properties of the product continuously. There are several types of digital twins such as component twin, asset twin, and so on. The next one is process monitoring and advanced sensor. The process monitoring and advanced sensor also it is fundamental to advanced manufacturing technology because it helps to maintain the quality, safety, and efficiency of the manufacturing system. Though by using the process monitoring and sensors, we can observe the how the operation is going on, or we can also observe the factory in through it. So this is a video of that IR camera, which is showing the how welding process is going on, how the metal is melting and solidifying is going on. By using IR camera, we can visualize the defects during the welding going on, and we can also rectify those defects during the process. So now this is the most trending topic in manufacturing. It means for future trending topic. It is some industries like Tesla, Siemens has adopted these techniques is the artificial intelligence and machine learning in manufacturing. So as we have seen that in the advanced manufacturing has a parts such as sensors. By using those sensors, we collect the data, and by collecting those data, we can transform the manufacturing industry to improve the decision making process, and can address the complex tasks and optimize the process, as well as we can reduce the overall production. So there are several types of AI and ML methods which are using in those manufacturing industries, such as supervised learning. Those are used for defect detection, quality predictions, and optimization of process parameter by using large historical data. Now, when large historical data is not available, how to do? With that time, the people are using unsupervised learning. By using the anomaly detection, cluster of machining behavior and process pattern, and the unsupervised learning methods is applicable in that mm, place. The next one is enforcement learning. By using this method, robots, additive process controls, toolpath planning, real-time optimization can be conducted. And the next one is deep learning, which helps to handle the complex data such as thermal images and acoustic signal. It can also use for mindful monitoring. And the next part of the advanced manufacturing technology is advanced material. The advanced materials are possessed as superior properties, and those are built for specific applications. As some advanced examples of advanced material is functional graded material, L smart materials, advanced structural materials, nanomaterials, circular materials, and smart coatings. This slide shows the comparison between advanced manufacturing and traditional manufacturing. As I described, the traditional manufacturing is used for mass production and cost efficiency, whereas the um, advanced manufacturing is using to high efficiency, precision, adaptability, as well as the technology which is using in traditional manufacturing is manual or semi-automatic, whereas it is a combination of robotics, AI, IoT, and automation. The production method I have already discussed, and the how the productivity effects in traditional manufacturing and advanced manufacturing due to the traditional manufacturing process has slower process the and low accuracy. The productivity of the traditional manufacturing is lower, whereas the due to use of robots, AI, machine learning, and additive manufacturing, the productivity of the advanced manufacturing is higher. The flexibility is very rigid in traditional manufacturing, whereas the flexibility in advanced manufacturing is highly flexible. However, for the skills, if, in traditional manufacturing, large number of labors are required with manual or no skills, whereas in additive manufacturing, the number of employee workers will be reduced, but highly skilled laborers are required to drive the advanced manufacturing technology. As the wastage of in traditional manufacturing is too high, so the buy to fly ratio of the traditional manufacturing is also high, whereas the buy to fly ratio of advanced manufacturing is low. The traditional manufacturing has higher to accidents is and humans are exposed to hazards, whereas the advanced manufacturing is safer due to the advanced equipments. Now those are technologies which has been added in advanced manufacturing in 2020, post 2022. Those are still in research stage. Those are not applied in the industries to. till now so now let us focus on India's net zero commitment. The government of India has announced the net zero emission and by and it has been targeted by 2070. The government of India has announced this net zero commitment in 2021. Now, what are the challenges in net zero commitment? First one is right now the some industries are highly dependent on coal. So it is hard to reduce the dependence on coal. Well, because the renewable energy storage are higher in cost till now. The researchers are working on reducing the cost of renewable energy storage is through batteries or some other processes. And the next one is the adaptation of green manufacturing technologies is very slow right now, so it is also a challenging task as the advanced manufacturing technology is required at high investment. So the financial is also a big challenge. The next challenge is the skilled worker. To adopt the new technologies, we need high skilled workers. So right now the industries are also facing on this technique. The next one is related to agriculture. The industries which are agriculture based, they the wastage which it produces through by agricultural industry are too high and it is very hard to reduce that one and the monitoring during the process is right now is not or in the process is still now. So thank you for your attention. If you have any question, please let me ask. That's all about.
Yeah, thank you, sir. Very wonderful presentation and very informative presentation. All slides are very much informative for us. So, among the participants, if anyone have any question or any queries, you may ask. You may unmute yourself. You may ask question regarding any query. Okay, maybe there's no doubt sessions. Uh, okay, as we reach conclusion of today's event, I kindly request Dr. Parna Goswami, Assistant Professor of Mechanical Engineering Department, to deliver the vote of thanks and officially conclude the sessions.
Thank you, Rahul sir, for giving me the opportunity. So, good evening, everyone. On behalf of the Department of Mechanical Engineering and the Institution Innovation Council, I sincerely thank our guest speaker, Dr. Atush Kumar Sinha, for sharing his valuable insights and industry experience with us today. The students truly benefited from the key highlights discussed, especially the guidance on industry trends, innovation, and career development. The interactive session gave them clarity and motivation for their future goals. My gratitude to our principal also, all the faculty members and organizing team for their support, and to all participants for joining and making this session meaningful. Thank you all for your time and active involvement. Have a wonderful evening. Thank you so much, sir, for your wonderful time. Thank you so much. And
Uh,
with this, I am concluding this session. Yes, sir. Yes, sir. Please.
Before concluding, I will advise to the students to focus those who are mechanical background. I will advise them to focus on AI and machine learning because this is the future trend of most of the industries. If they will not gain expertise in AI and machine learning, then they will
Yes.
may suffer in future.
Yeah. Sir, one question from my side. I have one
Yeah.
query. Just as all of us mechanical engineer and most of them available here mechanical engineers, what will be the future scope in next 5 to 10 years for the mechanical engineers in industrial purpose? Please explain to us so that we can know that.
Oh, okay, fine. I will first I will talk about where I am working. In next in next 1 or 2 years, our in this company is going to recruit some bright-minded fellows. And regarding the other manufacturing industry, I will advise the students to means if they are good in technical, then definitely they will get opportunities. But if they will not clear the basics, then it will be very difficult to survive for
Uh,
them.
okay, I understand. As we all of we know that all of the industry moving towards the AI and ML, and they need to go through this also. That AI and ML is very much important for them. Also, they need to start learning with these facilities, and they can take a chance in various companies as the human effort is less in the companies and the automated automation is growing in the companies, as I know, sir.
Yes. So you are right. So you means you have to structure the course according to that also. If this, when we have done our bachelor's, at that time we have not learned AI or ML.
Yes,
So,
yes.
or we have not means expertise in any programming language during our bachelor's day. But I have personally, for my interest, I have learned the programs like languages like Java and Python. So Python is the base of machine learning and AI. So for the students should focus on Python first, then they will jump on AI or ML.
Okay. Thank you so much, sir. Thank you so much.
Thank you.
Okay. Rahul sir, please conclude. You can conclude the session. I think all of you have done with this session. And again, I am thank you, sir, for your valuable time and valuable feedback and your valuable sharing the knowledge with us.
Thank you.
Yeah, thank you, Dr. Pandaguri. And this is the end of our today's event. So this message for the participant, those who are registered on today's event will receive within the 1 week e-certificate on your mail ID, registered mail ID. And those who registered but didn't participate on this event, they won't get the certificates. So all of you stay connected with that events like organized by mechanical engineering department and future or upcoming events. I hope all of the students should must attend the. Okay, you may right now today's end of the session. You may deep the session. Okay, thank you.